All right. Well, hopefully everybody did a good job finishing off the number lines, the colored counters, addition, subtraction, all that good stuff. So there are ways that you can do multiplications and divisions and stuff with colored counters and stuff like that. The main thing is what you're really doing is kind of using repeated addition. So I wasn't going to talk about it too much here. I was going to just focus more on just kind of regular old practice type problems. But if you were thinking about, like if you wanted to multiply, say, 3 times 4 using like colored counters, the easiest way to actually do this is actually kind of think of it in terms of an array in this case. And so what we would do is we would make, since these are both positive, we would use all blacks. So basically we'd use our colored counters and we'd say, okay, well, I've got a row of 3, but since I'm multiplying it by 4, I would just make 4 rows of those 3, and then I would just count up how many colored tokens I had. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I had 12 tokens in this case. So, and they're all black. So in that case, that would give me my 12, positive 12 for my answer. And so you can do the same thing with, if it were negative 3 times 4. So the only difference is, oops, let me do purple first. So if we're doing negative 3 times 4, then what we would do is again do our, so I've got 3 reds, and so I want 4 rows of those 3 reds. And so again, to figure out my answer, I would just add all these guys up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this case, I've got 12 reds, or negative 12 would be my answer. So again, all the stuff that we did with colored counters, you could do all the same kind of stuff with multiplication and division. So if you're interested, let me know. I mean, I can show you some more examples and stuff like that. But for now, I was basically just kind of focusing on some of the general properties of these guys and just going to leave it at that. So in this case, I've got all of our little properties broken down into adding, subtracting, and then multiplying, dividing, because they're both kind of the same. So when we're adding two numbers that have the same sign, so whether they're both positive or whether they're both negative, the cool thing is we always just add the numbers like normal, and then whatever our answer is, we attach the sign of whatever one. So like in this case, 5 plus 6 is 11, and since both of them are positive, we just leave our answer as positive 11, and we're done. So in this case, we've got negative 5 plus negative 6. So what we're doing is really just adding 5 plus 6 to get 11. But then since both signs were negative, then that means our answer has to be negative in this case. So again, if you're adding or just adding two numbers with the same sign, so it doesn't matter whether it's positive, positive, or negative, negative, just add like normal and then attach the appropriate sign. Now, if we're adding signs that are different, then technically, even though it's written as an addition, we're actually going to subtract our answer. And then the way we figure out what sign we get is all comes down to the number that has the biggest absolute value. So whichever number is the biggest absolute value, that's the sign that we would use. So like in this case, negative 5 plus 6, we're going to subtract. 6 minus 5 gives me a 1. And then when I go to look, so 6 is the positive number and it's the biggest, so that means our answer would have to be positive 1 in this case. So in this case, we're done. So same thing here, 5 plus negative 6. So we'd start off by subtracting them. So 6 minus 5 is 1. But since 6 is our biggest number in absolute value and it has a negative sign, then that means our final answer would have to be a negative. And so again, that looks good. All right, so what about subtracting? Well, really, since we've got nice rules for addition, it seems silly to ever deal with a subtraction problem. So what we actually do is we convert every subtraction problem into an addition problem by the following. So in this case, I've got a minus b. So remember, that's the same thing as saying a minus positive b. So essentially what I'm doing is I'm flip-flopping, changing that positive into the addition and changing that minus into the negative b. And by doing that, now I can apply all those rules above for addition and get my answers that way. So for example here, 5 minus 6, instead of thinking about it that way, I want to think of it as 5 plus negative 6. So in this case, I'm adding two numbers with different signs, so that means I want to subtract. So 6 minus 5 equals 1. And since my 6 is the bigger number in absolute value, then it's going to give the sign of the answer, which in this case will be negative 1. All right, so negative 5 minus 6. So again, let's convert this into an addition. So this is going to be negative 5 plus negative 6. So in this case, I'm adding two numbers with the exact same sign, so that means just add them like normal. So 6 plus 5 is 11, and since they're both negative, just attach my negative sign to the answer, and so that one I'm done. So again, negative 5 minus negative 6. So in this case, what I've got is, since I've got a negative times a negative, I can actually just multiply those two negatives together and give me a positive. So this is really the same thing as just negative 5 plus 6. So again, I'm adding two numbers together with different signs, so I want to subtract. And so I get 1. And then since 6 is the bigger number and it's positive, then that means my answer is going to be positive. So in this case, positive 1. And so finally, last one here, so which looks exactly like this problem I just did. Let's see, that's a typo, but anyway, I'll do it again, even though it's exactly the same, I think. So in this case, negative 5 plus 6. So again, I'm adding two numbers together with different signs. So 6 minus 5 equals 1. And the 6 is bigger, so again, the same answer. So I meant to have a different one down there, but I guess I messed it up, so sorry. All right, so for multiplying and dividing, so again, this one's a little bit easier because all we have to remember is if we ever multiply things together with the same sign, so two positives are a positive, two negatives are a positive, always, whether it's multiplying or dividing. So in this case, negative 5 times negative 4, the two positives are going to cancel, and it's just going to give me positive 20 as an answer. And negative 36 divided by negative 6, so again, the negative signs are just going to cancel and make it a positive. So I'm really just looking at 36 divided by 6, which is just plain old 6 in this case. All right, but if we ever are multiplying or dividing a negative, our answer is always going to be negative in that case. So in this case, negative 6 times 7, I can just go ahead and throw the negative in right away because one's positive and one's negative. So 6 times 7 is 42. And then 18 divided by negative 3. So again, since I only have one negative sign, I can go ahead and throw the negative down. And then I'm looking at just 18 divided by 3, which is going to be 6. So my final answer there will be negative 6. All right. So if you look, there's a big old practice problem here with, like, I don't even know how many, 24 different possibles, additions, subtractions, just kind of following those same rules that we were doing before. So go work on these. Who knows, this might be the exit ticket for you guys, a big 24-point exit ticket. So good luck. Let me know if you get stuck on any of them or anything like that, or if you need any help. I'll be around the computer all day, so enjoy.